Hi, this is Kevin Trainer, and I'd like to welcome you to my lecture on Chapter 5 from the Hoffer book, 7th edition, and Chapter 5 is entitled Initiating and Planning Systems Development Projects. So, this topic is kind of at the intersection between the practices of systems analysis and project management. And in this particular teaching of the course, I've been cutting back on the component of project management in the course because we cover that in other places in the curriculum. And I've been trying to beef up the systems analysis component to an even greater extent. But this chapter is one that really can't be separated from systems analysis because the kind of issues that we deal with here are the kind that systems analysts get pulled into all the time. So, to the extent that we're doing planning and initiating projects, well, a lot of the heavy lifting of that might easily be done by somebody who had the responsibilities of a project manager. But they can only do that well when they have the information that is gathered by a systems analyst. And of course, the project manager and the systems analyst could easily be the same person playing two different roles. So that's why I think it's important to concentrate on this when training a systems analyst. So I'm not going to go through the learning objectives as I typically don't. I leave them for you to read on your own. So let's talk about this activity. So initiating and planning systems development projects. This is an activity that is talking about this kind of activity. The people are really comfortable about this are people who are taking a traditional approach to managing software development projects. So people who take the traditional waterfall sort of approach put a lot of effort into planning. Okay. The Agile people talk about planning less, but if you concentrate on what's part of the Agile approach, there is planning that goes on up front. And initiating a project is something that really both the more traditional people, call them the waterfall people, and the Agile people talk about as well. When you are initiating a project, you are confirming that you have a group of stakeholders who are interested in the project. They do have an appreciable set of common interests, and that they can agree on doing the project. So we are going to initiate the project and get it started. So whether you're doing, whether you're taking a more traditional approach to the methodology of your systems development project, or whether you're taking an Agile approach, some amount of planning and certainly all of initiating has to be done. So let's move on here. So if we go back to the phases of the system development lifecycle as identified by Hoffer and the co-authors, okay? They are planning, analysis, design, implementation, and maintenance. So to do planning And I guess I would include planning and initiation in the same box. Okay, but to do that well, you have to sort of have done a little bit of analysis or all the analysis up front. Okay, for instance, you have to understand what the needs of the stakeholders are. You have to understand who the stakeholders are in the project. You have to understand what their problems and opportunities are. Um, and you are initiating a project to capitalize on those opportunities or solve those problems. And you're doing as much planning as is appropriate for the approach that you're taking. Okay? So, project initiation focuses on activities designed to assist in organizing a team to conduct project planning, as much planning as your group really believes in. So let's see. According to the Hoffer and the co-authors, who really come from the traditional kind of waterfall methodology approach to projects, here are things that would have to go on at this point. Establishing a project initiation team, establishing a relationship with the customer, establishing a project initiation plan, establishing management procedures, establishing the project management environment and workbook, developing a project charter. Okay, now these are all things that are expressed in terms of the traditional approach. Okay, from the agile approach, the things that you would have to do here is you'd have to establish your team, and you would have to establish a product vision and a product what this Scrum people call a product vision statement. Okay, so again, the agile approach is more lightweight at this point, but that's not to say that it doesn't have a corollary to what gets done at this point. So the key activity of project planning is the process of defining clear, discrete activities and the work needed to complete each activity within a single project. The objective project planning process is the development of a baseline project plan and a project scope statement. Okay? So those are, again, the traditional approach. I would say that in an agile approach, the things that you would be developing would be a product vision statement, some collection of user stories as an expression of what the scope is and the functionality that we are trying to address, and probably the organization of the user stories into some kind of a backlog which would prioritize them. Okay? Business case. Okay, so a business case is potentially a written document. In any case, it's an analytical exercise that one has to do, such that if one were asked to create a business case written document, that one could do it. And this would be true both in the agile approach and the more traditional approach. So it's a justification for the creation of an information system, or the acquisition of one if we're going to buy rather than make. It's presented in terms of the tangible and intangible economic benefits and costs. And the other thing that we want to address is the technical and organizational feasibility of the proposed system. So the traditional approach, elements of project planning, describe project scope, alternatives, and feasibility, divide the project into tasks, estimate the resource requirements and create the resource plan, develop a preliminary schedule, develop a communication plan, determine standards and procedures, identify and assess risks, create a preliminary budget, development a statement of work, set a baseline project plan. Okay, so that's a lot of stuff, and that's all from the traditional waterfall-oriented kind of school. Okay, what would the agile equivalent be? Well, let's back up and look. We would develop the product vision statement. Okay, we would identify user stories, which would identify the features that we are interested in. We would probably create a release plan, okay, which is a way to kind of ahead of time decide which features you think you're going to develop in what order, even though in an agile kind of project, the team and the product owner are free to commit to whatever user stories and features they want to develop in the next sprint. A release plan would give you kind of a preview. This is especially important if you intend to release the software for use in the field more than once in the project. So if in fact you're going to have 3 software releases, well, then you have to have some idea not only of the features you're going to work on in terms of user stories, but you also have an idea what order you might like to work on them to make sure that you have releasable units of software at the times you would like to do that. You do some estimation. People in the agile world who follow the Scrum approach have this way. There's an estimation approach where the team is asked to estimate every unit of work, which is typically a user story, or although it might be some other tasks that have to do with creating just kind of project infrastructure. The team is asked to assign an arbitrary number of points. And then there's approach to the points. We assign the points using values from the Fibonacci number series. And the Fibonacci number series is, it gets bigger kind of by doubling. It's something close to doubling. And that gives us some points to pick from in terms of the numbers that we're using in the estimation. Where we're not inclined to worry about the point estimates that we're given. Typically, we have to pick from a value or the next one that's approximately twice as big. So it gets pretty easy to hone in on the values that you want. So agile people who are following Scrum tend to estimate in terms of points, kind of arbitrary points. We ask each of the teams to come up with a sort of a consistent approach to estimation points for their team. There isn't an attempt to turn those into days. and there isn't an attempt to make the points comparable from team to team. Okay, but some of these other things, communication plan, well, there's a communication plan sort of inherent in the Scrum approach. Develop the preliminary schedule. The equivalent of that in the Agile world would probably be the release plan. Okay, so there are these kind of things that go on at this early part of the project, even though the waterfall approach is much more planning centric, and you're churning out probably more documents and spending more time here. There is a corollary to be done in the Agile project. Okay, so the baseline project plan, it contains the best estimate of the project scopes, benefit, costs, risks, and resource requirements. So that would be what a formal project plan from a waterfall methodology project would have. Again, the plan from the Agile project would be more brief, but it would address a lot of the same issues. Project scope statement, a project document prepared for the customer. It describes what the project will deliver. It outlines at a high level all work to be complete on the project. Okay, so a project scope statement is a waterfall project planning artifact. The equivalent in the Agile world would be a list of user stories organized into a backlog and prioritized. Assessing project feasibility. Again, this is something you have to do no matter what kind of project that you're doing. You're probably more likely to see a written analysis of project feasibility in a waterfall-oriented project. But in any case, whatever project you're doing, you've done the analysis of whether a project is feasible. And on what criteria are we going to judge it to be feasible or not? Well, here we have a list: economic, technical, operational, scheduling, legal and contractual, political. Okay. If we feel that there's a roadblock to this being a successful project on any of these, kind of axes, then we probably will stop and either try to correct that roadblock or we'll abandon the project. So here we have a typical thing that might come out of an IT department where people are following a traditional kind of a project planning methodology. They have this is a request for service, system service request for the customer tracking system. And so this is a description of what we would want to do in the project with some analysis of the feasibility. And of course, if we make a positive assessment, then we're going to believe that then we're going to do the project. And if we made a negative assessment, then we would not proceed with it. So let's talk about the feasibility stuff that we want to satisfy ourselves on. So economic feasibility is the process of identifying the financial benefits and costs associated with the project, often referred to as a cost-benefit analysis. The project is reviewed after each SDLC phase in order to decide whether to continue redirect or kill a project. So in the traditional waterfall kind of approach, okay, um, the approach is that we do a cost benefit analysis, and we do it on a pretty detailed kind of a level. And we would expect to revisit that as we get to the end of each of those SDLC phases, um, with the idea that we might have some kind of change. We might we're hoping to be able to continue on to the next phase, but we might stop. Um, this issue, in terms of an agile project, we still need to look at the economic feasibility of the project overall. In terms of how we go from phase to phase and we kind of analyze it, we typically have some length of time that we expect to conduct the project for. Let's say we're doing 3 week sprints and we're expecting to do 10 of them. So we're expecting to run the project for 30 weeks. It's consistent with the way we manage those kinds of projects that as we begin each of the sprints, it's possible for the product owner, who is, of course, representing the people who are paying the bill, to say, I think we have all we need. We just have to polish this up to perhaps, perhaps we need one more sprint to polish it up, and then that's going to be it. So there is always the possibility in an agile project that we might finish early if we decide that the economics are such that we've gotten really that we don't want to continue doing sprints. Okay, and that could happen for a lot of reasons. It could happen because the value that we've already gotten is higher than we thought we'd have gotten. This is plenty of value, we're done. Or it could happen the other way around. Maybe we're seeing that we're not really generating a lot of value out of the sprints, and we don't think it's going to get any better. But the decision points in the agile world are kind of sprint by sprint. Of course, there's a big decision point as you come to the point where if you're planning on 10 and let's say you're closing in on 10, then people begin to ask the question, are we going to stop at 10? Or is there some kind of argument for there being there being kind of incremental value to go to 13 or to stop at 8? There's certainly that kind of conversation. Okay, when we're doing an economic analysis, one of the things that we look at are the benefits. And benefits can be broken down into tangible and intangible. So what are tangible benefits? Well, this refers to items that can be measured in dollars and with certainty. So examples of tangible benefits include reduced personnel expenses, lower transaction costs, or higher profit margins. Okay, so if we increase the revenue that we get, if the scenario that we paint says we're going to get more revenue in, or we're going to reduce costs, those are benefits, and to the extent that we can measure them in dollars with some degree of certainty, then they're tangible. There'll be things like cost reduction and avoidance, error reduction, increased flexibility, increased speed, improvement in management planning and control, opening new markets or increasing sales opportunities. To the extent that all of those things are benefits, they are either going to increase the revenue that we have, or decrease the expected expense, or it could also decrease the variability in either the revenue or the expense, and in addition to the absolute amounts. Okay, so here we can see that we're doing an analysis of the tangible benefits, and you can just add them right up. Okay, typically you're going to do it in some time period. Here we're seeing what we would expect to get in tangible benefits over a 5-year period. Okay, and sometimes you'll see this in a spreadsheet where you see each of the years, and you'll see, for instance, a 5-year total. Now, benefits are not always tangible. So we have intangible benefits. Those are benefits derived from the creation of an information system, and the benefits cannot be easily measured in dollars, or they are uncertain. They may have direct organizational benefits, such as the improvement of employee morale, which we know is going to have some impact on the bottom line. Exactly how much is hard to measure. Or they might have broader societal implications, such as the reduction of waste creation or resource consumption. So here's a list on slide number 21 of potential intangible benefits from the development of an information system. And I'll just pick one or two to talk about. Increase organizational flexibility. Okay. Positive impacts on society. Better usage of resources. It's a greener system. So these are things that we know to be benefits. They're just harder to measure, or certainly harder to put a dollar value on. But still, they're things that we want to call the attention of the decision makers to. Now, we looked at the benefits, both tangible and intangible, and we're going to look at the costs, both tangible and intangible now. So a tangible cost is a cost associated with an information system that can be measured in dollars and with certainty. These might include hardware costs, labor costs, operational costs, including employee training and building renovations. And then we can also have intangible costs. That's the costs associated with an information system that cannot be easily measured in terms of dollars or with certainty. So these might include loss of customer goodwill, loss of employee morale, or loss of operational efficiency. When we're thinking about costs, we also ought to think about distinguishing between one-time costs and recurring costs. So a one-time cost is a cost associated with the project startup and the development of a new system. So these might include costs for systems development, new hardware or software purchases, user training, site preparation, data or system conversion. And then we have recurring costs. These are costs that are going to result from the ongoing evolution and use of a system. These might include application software maintenance, and that's including paying your own people to maintain the software, or paying a vendor some kind of an annual maintenance fee for getting updated versions of their software package. Incremental data storage expenses, incremental communications, new software and hardware leases, and supplies and other expenses. And here we see on slide number 26 an example of one-time costs, including development costs, new hardware, new software, user training, site preparation, etc. Okay, and as you can see here, we're only counting them at year 0, which is these are things we're going to pay for right in the beginning. Okay. And here's a spreadsheet on slide 27 with recurring costs. So application software maintenance, incremental data storage, incremental communications, new software hardware leases, supplies, etc. And we're going to get these in various typically we would expect these to happen in each year of operation. Now, it's a little bit ambiguous what the column of numbers is here with the heading year 1 through 5. Is that $25,000 in each year, or is that $5,000 a year for a total of $25,000? I'm just going to guess and say this $28,500 could easily be per year. Okay. So what kind of things are we going to look at? Well, we said we're going to look at one-time costs and recurring costs. We're going to look at we also have a distinction between fixed costs and variable costs. So fixed costs are billed or incurred at a regular interval and usually at a fixed rate. A good example of this would be, say, rent. And variable costs are costs that are going to vary in relation to usage. For instance, long-distance telephone charges. So here's a kind of a chart to talk about what some of the cost components of a software development project might be. I'll leave that for you to read on your own. Now, of course, when we're doing this sort of analysis, it's always good to have some guidelines when we're doing this. And of course, what we're doing when we're doing this is we are estimating. So we're estimating, we're guessing in a structured, intelligent way. So here are the recommendations. Have clear guidelines for this. Use experienced developers and or project managers for this. Develop a culture where all project participants are responsible for the accuracy of the estimates. Use historical data. Update the estimates as the project progresses. So begin to see how good your estimates were so you know how much you can trust the rest of your plan. Monitor progress and record discrepancies to improve future estimates. So, how do you take the kind of estimates over the life of a project that we just really talked about creating? How do you take that and analyze it? Okay, because these benefits and these costs are happening over time. And of course, today, with the interest rates as low as they are, we have a lesser impact from time value of money. As interest rate gets higher, the impact of time on the value of money is greater. But still, if we want to do this in an intelligent way, what we need to do is to make sure that we count costs or benefits that we get sooner, that we count them with a greater weight than costs or benefits that happen several years from now. So there are a couple ways to do this, and the one that is the most popular is called net present value. Okay, and that's it's the approach that we're going to recommend to you. So, what do you need to know to do a net present value calculation? Well, you need to know an appropriate interest rate. Now, we call that the discount rate because of the following thing. Let's say we're going to get $100,000 5 years from now. And then you say, okay, if the interest rate is 5%, okay, on the basis of the net present value calculation, that $100,000 that we're going to get 5 years from today is really worth less than $100,000 today. So the key thing is to get an appropriate interest rate. And how do you get that? You typically get that from your financial people. Now, you probably know from your own experience that when you go to save money, you earn at a lower rate than when you go to borrow, and that's unfortunate, but that's true. So the discount rate that we're going to use for this kind of analysis is usually some blend, or somewhere kind of in between what we could get if we put the money in the bank, okay, our savings rate, or what we would have to pay if we had to go out and borrow the money, which would be our loan or lending rate. So we definitely would pick a rate that would not be lower than what we would earn on our money if we saved it, and would not be higher than what we would pay for money if we were to borrow it. Okay, and how exactly to pick a value along that continuum, well, that's what financial people are for. Okay, so net present value is one of the ways that we compare cash flows. So when you use the net present value approach, you take the discount rate to determine the present value of the cash outlays and the receipts. There's another way to do this called return on investment, or ROI. And even though you hear people in the business world talk about ROI all the time, the economists and many of the accountants would say that the ROI calculations have a lot of distortion in them, and that the net present value formula is a more reliable a barometer of the goodness of, say, project opportunities. And then we have a third kind of analysis that we do, which is called break-even analysis, which is the amount of time required for the cumulative cash flow to equal the initial and ongoing investment, which is to say, when am I going to break even on this? Is it going to take me only a couple of months? Is it going to take me a year? Is it going to take me 5 years? So there's a formula for net present value, and I'm happy to say that it is a common function on business calculators, and it's a common formula available in spreadsheets like Excel. And so typically what you have to know is how many periods there are, how many years or months, and you have to know what the interest rate is per period, year or month, and you plug it in and you get the answer. You get the net present value. These are the same kinds of calculations that you can use to calculate loan payments. Okay, so this is if you go and get an auto loan or a mortgage on a home. This is the same family of calculations that they use to calculate your monthly payment. Okay, so you can do it that way, and you don't have to remember the formula because it's built into popular products. Break-even analysis is done like this. So the yearly net present value cash flow minus the overall net present value of the cash flow over the yearly net present value of the cash flow. So what we're trying to figure out is where we're going to break even. At what point in time, considering time value of money, we will be even. And the good thing about break-even analysis is that it does a good job of quantifying the risk that the world will change. Okay, because when we do the estimating associated with this sort of analysis, okay, we can have a couple of kinds of error. One is that we just might misunderstand what the benefits are or what the costs are. We might get wrong information. The other thing is, well, we might have right information to today, but the world is a changing place, okay? So the break-even analysis helps us with the second of those two risk areas, okay? Because if you look at this, the project that we see for the customer tracking system for Pine Value Furniture, it looks like the projected break-even point is 2.5 years. So a decision maker would ask themselves, well, is the environment that we operate in, is it likely to change between now and 2.5 years from now? Like how likely are we to get to this, or will the world change and we will never get there? 2.5 years is a medium amount of time. A lot of people who are really risk averse would like to see a payback in a year or less. Okay. People who are in maybe longer term stable industries or professions can wait to 3 or 4 or 5 years. Another consideration that that impacts people is that how long will the management team stay in power in light of how well things are going economically for the organization. So you take a project like the one that we see here and we say, well, a year from now, we still will have invested more than we've gotten back. Well, maybe a management team that already feels that they're on the ropes and they need to prove themselves in the next year, well, maybe they wouldn't be signing up for something that's not going to turn positive for 2.5 years. So that's always a consideration. So break-even analysis is pretty insightful stuff. Now, in addition to all this economic feasibility for a project, it needs to be technically feasible as well. Okay, so Technical feasibility, a process of assessing the development organization's ability to construct a proposed system or to buy one that's already constructed, either one. The potential consequences of not assessing and managing the risks include a failure to obtain the benefits, incorrect cost estimates, incorrect duration estimates, not meeting the performance levels that you're expecting, or perhaps not being able to integrate the system into your organization. So what are project risk factors that you might want to consider on the technical side? Well, the project size, how big is the project overall, the structure of the project, the capabilities of a group of people who might be developing this software for your organization, and the capabilities of the user group. So here are the ways that those factors might turn into higher or lower risk. Most knowledgeable people feel that larger projects are riskier than smaller projects, and history seems to bear that out. A system in which the requirements are easily obtained and highly structured will be less risky than one in which the requirements are messy, ill-structured, ill-defined, or subject to the judgment of an individual. The development of a system employing commonly used or standard technology would be less risky than one employing novel or non-standard technology. Most people would agree to that. A project is less risky when the user group is familiar with the system's development process and the application area than if they are not familiar with that. So that's the way a lot of those considerations can come to affect technical feasibility. Here's a typical management consultant's chart. Here we're taking we're trying to take the risks that we talked about in the last section and put them into some kind of a chart to help us with the decision making. So we've got projects are large or small. We either have high familiarity or low familiarity with the technology of the application area, and then when you walk over to the right side, depending upon if you have a lot of structure or very little, you can figure out where your risk is. Now this is, I think these are kind of interesting thoughts. Are these absolute truths? Well, probably not, but it's an interesting way of thinking. And how about other feasibility concerns, like operational feasibility? Does the proposed system solve the problems or take advantage of the opportunities? Okay. Again, before we kick the project off, we have to have some level of comfort that what we're doing is really going to be beneficial. Scheduling. Can the project time frame and completion dates meet the organizational deadlines, or are we just going to miss the boat? Legal and contractual. What are the legal and contractual ramifications of the proposed system development project? Are they straightforward, or is it a bucket of snakes? And political. How do the stakeholders view the proposed system. The stakeholders are the people affected by the project, positive or negative. If most of the people to be affected by the project don't buy into it, well, it may not be a politically feasible project. So, a baseline project plan is a name that they give to a fairly extensive project plan that would come out of a traditional waterfall project planning effort. And it could have a lot of sections in it: introduction, system description, feasibility assessment, management issues, um, statements of project scope. I have a whole bunch of stuff here on slide number 44. Now, if you are involved in the initiation of an agile project, okay, you're probably generating significantly less paper, but there is some paper that we generate. I mean, we do generate a project vision, a product vision statement. We do identify user stories. We do organize them into a backlog. We do come up with estimates for the user stories and other work that has to get done. We do, for instance, have a software release plan. So it might not be as extensive as what's going to come out of the planning for a more traditional waterfall project, but it's not insubstantial, and it has a lot of the same information in it. One of the biggest issues of organizing a project is deciding scope, what's in and what's out. Okay, and who's in and who's out. Okay, so here are some of the factors. You have to consider the organizational units affected by the new system, current systems that will interact with or change because of the new system, people who are going to be affected by the new system, and a range of potential systems capabilities. And here's what I tend to want to tell my students about how to pick a scope. Okay, if you pick a scope that's too small, okay, it doesn't solve a problem for enough people or organizations. Or you pick one that is too small because it doesn't really address enough functions. One of the things that happens is that you just don't get any interest. It kind of fizzles. It's just like, yeah, we can feasibly do that, but who cares? Okay. Then, as you begin to add people and organizations into the scope, then you get a lot more interest. But they're competing interests. Okay. So what happens is that at a certain point, either you get too many competing interests to come to consensus about what the scope should be, or you just get so much work that it can't be finished in some kind of a useful time period. So when dealing with the scope of a project, the planners, who include systems analysts, the challenge to them is to not wind up too small or too big. It's sort of like the Goldilocks and the Three Bears. What they need to do is that they need to pick a scope that is just right. Okay? The tendency of people who are new at this is to be overly ambitious. So if there's a tendency, to err, it's, on having the scope be too big, to have too many players involved, to have too much functionality included. So I tend to coach people who are new at this to be conservative in their commitments, but not so conservative that what they're agreeing to do is simply trivial. Now, the diagram here on slide number 46 is from the first of the diagramming methods that we're going to learn in the course. It's from data flow diagrams. And this is the top level data flow diagram. In fact, the only one that we're going to use on a regular basis. It's called a context diagram. And what it essentially does is it identifies the system so that rounded corner rectangle that's in the middle labeled 0, purchasing fulfillment system, that represents the system. It also represents the users of the system, both people and other systems. So in this case, we've got production schedulers, suppliers, and engineering. And then we represent the flow of typically information, but sometimes it can also be material into and out of the system. And that very interestingly describes the scope of the project, because who's involved in terms of people or other systems that we're going to serve? Well, that's part of the scope. And then what's the functionality? Well, you can really see the net functionality of a system well when you're looking at what's the data that flows into it and flows out of it. You know, what are the net inputs and what are the net outputs? So this is a pretty good expression of scope, which is one of the reasons that it's the first diagramming approach we're going to cover in the course. Here a whole bunch of things for the baseline project plan, all kinds of different parts to it. It's something that can be very important to do with any kind of plan, is to walk it through with the players involved. And there was an approach to walking through plans and also technical products like programs that was introduced in the 70s called structured walkthroughs. And of course, the authors of the text kind of grew up on IT in the 70s, so they still like to talk about those. But this idea that we would take our plan and walk it through with the parties involved and get their feedback is as appropriate today as it was, in 1975. And then we come to the summary. So I just want to take a second here and talk about the importance of the stuff we talked about within the chapter to the systems analyst. Okay, this planning and initiation is work that has to go on really before you kick the project off. It's the process of kicking the project off in a formal way. Okay. And to do that well, you have to understand the people who are going to be involved in the project. You have to understand the stakeholders, the people who are going to be affected by the project, either positively or negatively. Now, who comes to understand that well? Well, systems analysts do. Systems analysts are the people who go talk to the candidates for new information systems and come to understand their needs and their wants and their capabilities. So the systems analyst is going to be a major player in this kind of analysis. And then what kind of considerations are investigated in this early part of the process? Well, generally speaking, a word that we've used for a long time, it's almost sort of an old-fashioned word in IT, is feasibility. We used to talk about feasibility study, feasibility analyses. But that's what we're trying to decide. If it's feasible, we're going to go ahead. We're going to continue on. So what kind of feasibilities are we concerned about? Well, financial. Okay. Typical organizations don't want to go spend and then find out that they're in a worse position for doing that. And that's why we learned a lot about cash flows, time value and money, net present value, break even analysis, all those things. Okay. But it's not only financial, it's financial, technical, organizational, schedule wise, all those things. And again, the systems analyst isn't the only person involved in all those things. Certainly, the project manager will get involved in those kind of analyses, and senior people from the user organization and from the finance department. But the systems analyst is going to be a player at the table, and it's pretty important to understand these kinds of considerations so that you have the perspective that you need to be a player in this kind of early part of the project. So I'm not going to go over the summary. I'm going to leave that for you, and I'm going to say bye until next time. Bye bye.